Welcome back to another Hamsafe DevLog. With animation ready, it was time to build the logic that controls how a player selects their characters during gameplay. Rather than stuffing everything into one blueprint, I kept things clean and modular by creating a reusable component, introducing BC underscore character changer. Think of actor components like the little parasites. They latch onto an actor and use its resources. They don't exist independently, but they can read, modify, and control whatever actor they attach to. In this case, BC Character Changer is my parasite that takes over movement, rotation, camera zoom, and of course switching the Skeletal Mesh if we switch the characters. Inside the component, I created a series of functions called getBasicHostStuffs. It will contain two parts. The first part is get character variables, and here's what it does step by step. First, we get the owner. The component fetches its parent using the getOwner, and then from that owner, I cast to character. I cast this to a generic character to access control and movement data. This way, we can put this actor component into any other actor that has a character, and we set movement references, so I cache key variables from the character such as character movement, maximum walk speed, and rotation rate. These are saved into the default variables, so I can restore them after exiting the selection mode. So for example, we might set the max walk speed to 0 when we are changing characters, so the character won't move anywhere, but we restore the max walk speed if we are done changing the characters. Second part is we are getting BP components by casting to BP hamster chef. While most of values could be accessed through the generic character reference, there's one exception. I wanted to control the target arm length of the spring arm component hosting the camera. To access that, I had to cast directly into the BP underscore hamster character. Even though it's not dynamic, this let me pull the spring arm's target arm length and store it, just like the movement variables. While at it, I also get the follow camera and store it as a value in case I need them again. When building a character selection system, hard coding every single character asset is a maintenance nightmare. Every time a new character is added, you'd have to manually update the list. It's very inefficient. To solve this, I use Unreal Engine 5 Asset Registry system to automate the process. With a single node, get asset by path, I can scan any folder like the game/characters and get a list of all of the assets inside without loading them. But I actually tried to build this system multiple times, only to find out that the only way to do this is to create primary data assets from the blueprint class, then create a data asset from that primary data asset. The logic is that I store every string of both the skeletal mesh and its ABP in the PDA, primary data asset. So in game, we will only need to read this list whenever I want to change characters. So no need to rescan the entire folder every time. The folder scan still happens, but only as one-time operation when new characters are added. After that, everything is centralized in the PDA, which my character selection component can reference directly. How do we do this is basically when the directory scan happens, we check if the string of the scale mesh and ABP is already on the list in the PDA. If it's already on the list, then we're not adding them to the PDA, and we will build the logic shortly. After calling get assets by path, each result is validated using brick asset data. We extract the path and the name, and then from that package name, we apply two string-based filters. The first one is filter is the scale mesh string to avoid. So the name must not contain Mannequin, because Mannequin is the default Unreal skeleton, so we won't be listing that. And then the second, the scale mesh string to find, which is The same with the name must contain scale mesh. And then we get the class, and then using the filter equal, the name is equal. So, and then we just filter it, the result, by skeletal mesh class. This way, we exclude Unreal's default mannequin and include only properly named character meshes. The filtered results are stored for use in the character selector later. Once we've got the correct skeletal mesh path, I use that same path again to search for its corresponding animation blueprint. Here's the trick. So from the skeletal mesh package path, usually something like game/character/hamster/meshes, we just need to go one folder up using the split node, so we're back in the characters/hamsters, where the animation folder typically lives. From there, we just look for any assets that contains ABP in the name. Once found, we need to use append _c to the asset name to form a soft class reference name. Somehow, a name blueprint have a different ending from the other assets in UE. Usually, the path in the UE assets is just path/hamsters_abp dot hamster_abp is just repeating after dot. But for any blueprint, we need _c at the end. So this is just a little bit of hacky workaround right now. I don't know how to directly get something like ABP hamster as a class reference cleanly. The Unreal way wants us to do with an blueprint type of filtering, so we're relying on the _c suffix to manually form the path of hamster ABP or the squirrel ABP path, or just any character's ABP path. We'll go back to this very later.
In the dark, drawing cold blood, hide away.
Remember why we use PDA or primary data asset? Right now, the game still runs on a folder scan every time one begin play. But thanks to the PDA, we're not constantly just reading from this folder scan and start clean every time. We're not reading and listing the same stuff from that folder scan every time. The solution was just to store what we read from the folder scan to a data, a PDA, a list. And with that list, we will able to do something like skipping. So if a character is already exists in the list, then we're not adding it anymore. We're just skipping it. We only add the characters that aren't yet on the list. And that is what we are building here. By grabbing the PDA, getting the skeletal mesh array of string, and using find node to check, it will return -1 if it false, and we continue from that. And then getting the skeletal mesh with ABP, a data map, we're doing the same thing. I actually forgot to set the skeletal mesh with ABP data is not just an array of string, but a string and a string, so we make it as a map, so it got both string as one data, so it's like pairs. And then we get the skeletal mesh with ABP map, and then using the find node, and then we are finding if any of the string that we got from the folder scan is exists. If we are not finding anything, that means it's a true, and we continue from that. Then it's only a matter of adding all of that data that we found into the PDA. So we'll grab again the PDA scale mesh and the PDA scale mesh with ABP, and we're adding the scale mesh string to the scale mesh array of string in the PDA, and then we also adding it to the scale mesh with ABP, the first pair, because it's a pair data and it needs 2 string. And then we grab the ABP path and then fill it to the second string in the pair data on the scale mesh with ABP pairs of string. Yeah, and that's about it. And maybe for efficiency, for more efficiency, I might actually turn off the folder scan entirely in the package build. So by then, the PDA would already contain every character, so there's no need to rescan the folders at runtime. Now that the whole collection data of the skeletal mesh and its ABP are complete, we actually just need to test it. So let's go hit play, and it does nothing because I actually forgot to just plug it in the BC character changer to the BP hamster character viewport. So let's just plug it in. It sits in here, components, character changer, and let's just drag it into our BP hamster character and plug it like here. It will be added as a component. Hit compile and hit save, and let's try again. It still does nothing, actually, because I forgot a lot of things. So the second one is we need to set the mannequin string of the scale mesh string to avoid. I put it in the comments, but I forgot to actually put it into the string. And so does the scale mesh that we need to find on the scale mesh string to find. And after that, I also forgot to actually put the data assets to the PDHR list. I don't know how it got lost. And then if we just try to print here, we can see that in the top left, we actually correctly printing the scale mesh that we found. So yep, we found it, and it should be got put in, but no. Let's see what's next. So we need to put recursive on the get asset by path. I actually forgot to put it recursive on the footage before. And then the next one are we are actually not correctly backwarding on the character string, so it actually sits in mesh. If you see that the print, and we need to backward once more. There's two ways, so maybe the first way is we just backward once more like this. So if we just plug this in and then we plug from the left to the backwards once more, we can see that it's correctly now sits on the character level, not the meshes level. And the second way is actually not using the scale mesh string. So we can actually just use the package path. So from here, package path. So package path actually does not contains the scale mesh edge. So if we just directly print like that, it should be working. And I guess I'll be using this method. If you are following, feel free to do what's necessary in terms of searching assets within the strings of the paths, and then it will go through the filters, and yeah, I think that's it. And now we can see that it's actually populated the data assets, and you can see that it populated the scale mesh list and then this scale mesh string with the ABP besides it. Let's try once more. Let's try clean this up and press play, and we can see it successfully populated the list. Yeah, and then that's it. Now we are ready to use all of this data in our character changer or character selections. That's it. Thank you for watching. See you guys in the next one. See you guys in the next content. See you guys in the next video. And don't forget to subscribe, like the video, and thank you very much for watching.